Let's study what is inside the Arduino Uno. So the Arduino Uno consists of ATmega328P. It's the main microcontroller which do all the processing. Inside this microcontroller, we have SRAM, which is static random access memory, which store all the program data. It has flash memory for storing the program. So whenever you download the program from the laptop in the Arduino Uno board, it gets stored in this flash memory. It has electrically erasable programmable read-only memory which retains the data even after powering off the Arduino Uno board. So it's the non-volatile memory. It has timer counter circuit for doing the timing related operations like generating precise delay or for generating pulse width modulation signals. It has 10-bit analog to digital converter which convert the analog signal into digital signal. So our microcontroller has two state, either 5 volt or 0 volt. So this is digital circuit because it has fixed set of values. So 5 volt is also known as on, 1 or high, and 0 volt is also known as off, 0 or low. So the Arduino Uno board have DC power jack for providing the power. So using this power jack, we can provide power to our Arduino Uno board. Either we can connect battery in this power jack or we can connect AC to DC adapter in this power jack so that our Arduino Uno board can run. So the input voltage can be between 7 to 12 volt. If we provide less than 7 volt, then the Arduino Uno board will not work properly. If we provide more than 12 volt, then the voltage regulator overheats and it will damage our microcontroller board. So we have to provide the voltage between 7 to 12 volt. Then we have a USB port using which we can download our program from a laptop in this development board. Using the same USB, we can also provide power to this Arduino Uno board. Since our microcontroller ATmega328P requires a stable 5 volt in order to work properly, so we have a voltage regulator which converts the input voltage into stable output voltage of 5 volt. Then we also have another voltage regulator which produces the output of 3.3 volt. Then we have power pin. So you can see in top and bottom we have header pins. Using this header pin, we can interact with our microcontroller board. So using this header pin, we can easily connect any electronic component or sensor and we can easily interact with our microcontroller board. So in this power pin, we have VIN. So using this VIN, we can also provide power to this development board. We can connect our battery in this VIN pin so that our microcontroller board can run easily. Then we have two ground pins. We have 5 volt which we get from voltage regulator. We have 3.3 volt which we get from another voltage regulator. We have reset pin for resetting our microcontroller. We have IRF pin which is input output reference voltage which provides the reference voltage of the microcontroller. It is useful for connecting external component like Arduino Shield. Then we have manual reset button using which we can reset our microcontroller. Then we have diode to protect our microcontroller from reverse polarity. Suppose if we connect the battery in reverse direction, like if we connect positive negative sign in reverse direction, then it may damage our board. So in order to protect our microcontroller from being damaged, we have diode. Then we have another microcontroller, ATmega16U2. It convert USB to serial communication. So whenever you download the program from the laptop, it has to be transferred from the USB port to the ATmega328P. So this ATmega16U2 small microcontroller act as a bridge between this USB port and the main microcontroller ATmega328P. So this small microcontroller ATmega16U2 help us in communicating the data, help us in sharing the data between the USB port and the ATmega328P. Then we have a 16 megahertz crystal oscillator. So it is clock signal for ATmega16U2. So it provides timing signals so that our data can be shared reliably from the USB to the microcontroller. So it provides the precise timing signals. So you will see in future when we do serial communication, we will set baud rate. In order to share our data at that particular baud rate, we need precise timing signal. So this 16 megahertz crystal oscillator provides this timing signal for this ATmega16U2 chip. Then we have 16 megahertz ceramic resonator. It's the clock signal for our main microcontroller Atmega 328P. So you already know that we have CPU of 2 gigahertz or 2.5 gigahertz in our laptop. So it means that the laptop has 2.5 gigahertz of clock signal. So similarly, in this microcontroller, we have a 16 megahertz clock source. Then we have analog pin A0 to A5 using which we can provide analog signal in this microcontroller. Like we can connect temperature sensor, light sensor or any sensor which have analog output. Let's see this example. In this example, we are using potentiometer to get the analog input in the microcontroller. So with the help of rotation, we are controlling the brightness of a LED. So these analog pin A0 to A5 are connected with the analog to digital converter in the main microcontroller. So analog to digital converter convert analog signal of our sensor into digital signal so that our microcontroller can process it. Then we have digital pin using which we can provide digital output or we can take digital inputs. Let's see this example. In this we are taking the digital input, either we are pressing the button or either we are not pressing the button. Let's see this example in which we are either turning the LED on or off. So this is digital output because it has two state, either on or off. In digital pins, you can see there are some pin number which are preceded by a tilde sign. So these are pin using which we can provide the pulse width modulation output. So using pulse width modulation, you can provide the analog output. Let's see this example in which we are producing the analog output. Here we are changing the brightness of LED. So this is analog output because here it has range of values. Then we have pin number 0 and 1 for serial communication. So these are connected with our USB port. So whenever you download the program from our laptop in this microcontrollers, then these pin will be used for serial communication. Then we have a pin for I2C communication. These pin are also connected with the A4, A5 of the analog port. So these two pin are duplicate of each other. So then we have analog reference voltage. So this is the external reference voltage from analog to digital converter. It helps us in setting the upper limit of the analog to digital converter. Then we have another ground pin. Then pin number 10, 11, 12, 13 are used for SPI communication. And we have 5 volt on indicator LED, which turns on when we connect our Arduino Uno board with the power source. Then we have transmit receive LED. So these LED will glow when we download our program from our laptop in this Arduino Uno board. So when we do serial communication between the laptop and the microcontroller, these two pin will glow. You will see that transmit receive LED will glow. Then we have in-circuit serial programmer header for ATmega328. Using this also we can download the program. So I hope you have learned a lot. So if you find this video helpful, please like, share, subscribe and comment, and we will be meeting in the next video. Bye bye.